limit the scope so you can actually get something into production. Because I found like once you have the foothold and you have like something running in production, then it becomes easier to motivate the next project to improve it. Because you can say, oh, it's working and it has some impact. Here's the next steps. And if we do those, then it'll be even better, or it'll be where we need it to be.
Hello, everyone. Welcome to the Data Scientist Show. Today we have James Verbus. He is a staff machine learning engineer at LinkedIn. He has a PhD in physics from Brown University. He's a tech lead of the anti-abuse AI team, working on protecting LinkedIn's members from bots and abusive scripted behavior, pioneering the use of deep learning to detect abusive automated sequences of user activity. Today, we'll talk about his work in deep learning's application in online abuse detection and how he grew from a physics PhD to staff machine learning engineer at LinkedIn. And if you have been enjoying the show, give me a 5-star review and subscribe to the channel. Welcome to the show, James.
Hey, Daliana. Thanks. Really happy to be here. Thanks for the invite.
Yeah. So how did you get into machine learning?
Yeah, so I started in physics. I was really interested about, how the universe works. And even back when I was in high school, I would watch these documentaries, and that was kind of my initial passion. And I ended up going to, pursuing physics in undergrad, deciding I wanted to go to grad school, pursuing physics there. And at that point, there wasn't really, the term machine learning maybe existed, but I wasn't really aware of it. Data science wasn't really as popular the way it is. It wasn't really a popular term. And I really got an awesome opportunity in graduate school to do a lot of data analysis, use some related techniques like Monte Carlos and maximum likelihood fitting of physical models to data. And sort of by the end of my time in grad school, data science and machine learning had really taken off and was a really hot topic at that time. And a lot of my friends and colleagues that I had built close relationships with started making this transition. So I could see around me like, hey, a lot of people are doing this and they're doing it successful. So that motivated me to kind of check that out and look for opportunities there. And I actually, so after I got my PhD, I started applying. I was on the East Coast and I started applying for some of these data science jobs. And it was tremendously difficult actually to get any callbacks because I think if you're coming from a non-CS background, maybe you don't fit the profile of what big tech companies were looking for at that time. And this happened to a lot of other people I knew as well, like they were coming from physics or other sort of non-CS academic areas. And I had a lot of friends that went through this Insight data science boot camp, which just was about 7 weeks long, and all the people I knew were having great success with this. They were, they do a project, get their foot in the door, get a few tips on interviewing, and they were all getting jobs. So I applied to that, got in, and then that's when I moved out to the Bay Area to participate in that program. And that got my foot in the door at LinkedIn, and that's where I've been ever since for the last 5 or 6 years.
Mm-hmm. Yeah, thanks for sharing that. Thanks for sharing that journey. And so from your degree and courses in physics, how did those knowledge help you become a better data scientist? Are those helpful at all?
Yeah, that's a great question. So I feel really lucky about the background I was able to get doing physics. So I worked in grad school for almost a decade, undergrad plus grad school, on the same experiment, a collaboration of an order of 100 people and maybe 10 to 20 institutions that were working to detect the missing mass of the universe, which is dark matter, which is kind of a popular term. And this is made up of particles that are in this room now, and they're kind of ghost particles that pass through the Earth and without interacting, and very, very rarely they can interact with normal matter. So we spent the better part of a decade building a detector a mile underground in an abandoned gold mine to detect these, to be the first to detect them. And if we were able to do so, there's probably a Nobel Prize for the leaders of that experiment. So it's kind of a worldwide race, and lots of different groups and people have tried to do this for decades. It's a big unanswered problem in science and in physics. But one of the cool things about that background and that experience was it's kind of like working for a startup in some sense. It was the right size where there's an enormous amount of work to do, and you have to design the experiment, build it physically, turning wrenches and being on site doing it. And there's often like novel challenges to solve in doing that. You have to end up going there for a few years on site in this abandoned gold mine to run it and take data. And it actually produces a lot of data out of this experiment. And then you have to write the software to analyze the data. And it's typically some like bespoke data processing pipeline. And in fact, I had a big hand in that early in my time there. Before the experiment was ready, we were preparing to process the data. And then once you process the data, there's a lot of data analysis. And that's where you're using these techniques like Monte Carlos, and you're using maximum likelihood techniques and measuring physical parameters by fitting physical models to data. So that overlaps a lot with some of the ideas in machine learning. And
sorry to interrupt. I'm just curious, what is the data type of the data in physics?
Yeah, that's it. In this particular case, we I can talk a bit about how the experiment works. If that sounds good. Cool. So it's so these particles rarely interact with normal matter, and the name of the game is to build a big detector that's sensitive to an occasional WIMP dark matter particle coming in and bumping into a normal atom. And you can kind of think of it as like a billiards game where the WIMP is the cue ball and the stripes and solids are the atoms in your target. And when a WIMP comes in and hits the normal atom, there's a little bit of light that's given off, a few photons of light and a few electrons, and we are able to collect those actually in our detector. And they're collected in a way, the photons can be detected immediately using light detectors that are sensitive to single photons. And the charge, the electrons, are actually drifted up to the surface of our target, which is liquid xenon. And there's a lot of reasons why that's a great target, but they're drifted up to the surface and extracted into the gas, and they create another big burst of light. So the same light detectors can detect the initial photons and then also the secondary photons from this charge. And our detector was a big bucket of this liquid xenon target, and it's lined with light detectors on the top and bottom. So there's 122 of them, and they're waveforms. So it's like time series data that comes out of each one.
Yeah.
And they're constantly digitizing the amount of photons they're measuring. And you can do a lot of cool things from looking at these waveforms and reconstructing what's going on in the detector. Yeah. So it's kind of a time series problem where you convert the time series data into sort of features that we call them RQs or reduced quantities, but really they're kind of features that you can then use in your analysis pipeline.
Oh, cool. So you already have been working with sequence data.
That's right. Yeah, it's a sequence data of a different type.
Right.
Yeah.
And do you know whether physics researchers are using deep learning like RNN, LSTM for those tasks?
That's a great question. So when I was there, they were not using them that frequently. There might be some researchers that were, but like we weren't. And I think there's like I know actually of in the past, like maybe decades, even early in the 90s, I remember reading some theses where people were using neural networks to do this type of time series analysis. But at that time, it was very early, and computational power wasn't great to do that effectively. I think there's like a hesitancy in sort of the basic sciences, like especially physics, to have like black box type models. Yeah. So you may see it in cases where you're creating features or you're filtering data, like maybe your detector produces a ton of data and you're really interested in particular events in it or particular things, and then you can use deep learning or machine learning to filter what you're interested in from what you're not interested in. But I think like a lot of the fundamental bits are physical models, which like map back to like, hey, this is the way we think the world works.
Yeah.
And fitting those to the data you observe.
Okay.
Yeah.
So it's really based on those theories because you want to know what exactly happened.
Is the theory right or not? Or if you want to measure, you measure something in your detector and you say, okay, what's the mass of this particle? Given this theory we think is correct, and we've observed the signal in our detector, can we measure certain parameters in the theory and put error bars on them and do that by fitting the model to the data and see which parameter values work? Oh,
interesting.
Yeah.
So there's still a model fitting part, and then are you using any probabilistic models? Do you give any like estimation for that?
Yeah, it is probabilistic. So it's again like lots of Monte Carlo. So it's often like you create PDFs based on, you simulate the background you'd expect in your detector, so signals that you don't want to see, and then there's like in this particular case, it's almost all background. These particles interact so infrequently that you'll run the detector for a year and maybe see just a few of them, if they even exist. And you're kind of swamped with background. And so you have to be very good at differentiating between your signal and your background.
Yeah.
So there's a lot of techniques that we did. Some are like in the design of the experiment and some are in the analysis to do this. So like we actually put the detector a mile underground. Yeah. And that's because there's a tremendous amount of radiation from space called cosmic rays.
Right.
So if you hold out your hand on the surface here, there's one of these radiation particles that passes through your hand per second. And if you go a mile underground, it's about a factor of 10 million less. And it's maybe one per hand per 3 or 4 months.
Yeah.
So you use the Earth to shield yourself from this radiation. So that's the first step. And then we put this detector, which is, half a meter by half a meter of liquid xenon bucket, and we put it in the center of an 8-meter diameter water tank. And that knocks down the backgrounds considerably as well, because the radiation doesn't travel too far in the water. So you have it in the center of this big shield. And then we do something cool, which is we measure the background contributions from every piece of detector material, because they all contribute radioactivity that would look like our signal potentially. So we wanted to get it as low as possible. And even if there is some radioactivity in our materials, we want to know how much. So in our simulations, we can model the background and make PDFs of what the background look like.
Right.
So we do that. And then there's techniques in data analysis that allow you to look at the shapes of the signals and where they happen in the detector, and differentiate between signal and background that way. So you do all of these different things, and then you can run your detector for a year and say, okay, if there would have been a few of these dark matter events, we would have seen them. And that's how. And then you can say, hey, we did see it, and that's a great discovery. Or you can say, we didn't, and we know it interacts at least this infrequently with normal matter. So that was kind of, I spent a decade doing this, and I learned a ton. Yeah. And a cool thing about those collaborations is you get to really have ownership. There's so much work to do, and there's so few people that even when you're very junior, you're fresh out of undergrad, you end up getting to own really critical parts of the experiment, and you're kind of put in a spot where you have to make it work. Right. And I think that translates super well into industry, because if you take that mindset into projects that you're working on, you're less likely to be intimidated by fuzzy or unknown situations where you have to just figure things out. And I think that's helps a lot. Yeah,
definitely want to talk more about your learnings from your career journey. I think that's really cool. You work on those physics detectors, and it's like the dark matter of the universe. It probably feels like everything else in life is just not important while you're working on things like that.
So I was super excited with it at the time, but there's actually a sort of a natural thread from the dark matter work to detecting abuse on a social network. And you can kind of think of it, I was describing all these backgrounds, right? So we're looking for these very rare events in our data, and they're swamped by background, and there's all these techniques you use to find them. And you can kind of think of the same thing on a social network. There's, hundreds of millions or more users, and they're all active, and they're, visiting different pages and sending messages and posting things. And that's kind of the background. And then there's rare cases of fake accounts or bad actors taking over the accounts of legitimate members, or people using automation to send spam or copy data. And all of those things are bad. So we're again looking for this like very rare outlier class in this vast ocean of background normal user behavior. So like that's actually a constant, I think, through my work.
That's super interesting. And I definitely want to talk more about why you give up the potential to get a Nobel Prize and go into
wouldn't have been me, but the leaders of the experiment maybe if we would have found it. But
when I think about the data in physics, when you talk about a lot of frequency, so basically you're dealing with a lot of data with high seasonality, those type of patterns. I think sometimes it might not exist in other type of data. For example, when you think about like online abuse, maybe that's kind of the biggest difference when you work on the physics data. You're looking at the frequency, the patterns. So those are the things maybe you don't really need a deep learning to define that. You can create some features using the theory. And also I read your technical blog. By the way, you can find it on James' LinkedIn profile. He published a blog about his anti-abuse work. And I think in the blog post, you mentioned a lot of traditional machine learning method. You create some features which kind of fail to detect those outliers. Can you talk more about that?
Yes. Yeah. So I could talk about the outlier detection work initially. Yeah. So this is one of the things I did sort of in the middle of my time at LinkedIn, which was I had been. I think this is generally a good thing, when you first start, especially if you're fresh out of school, but also, if you start a new company, it's great to focus on execution first. Like, people have been there for a lot longer than you have, and there's a reason they're doing things a certain way. And you can, observe and make contributions and execute effectively and build people's confidence in you. And then, though, after you do that for 6 months or a year or, until you're comfortable, you can start to see, hey, there are gaps or there's an acknowledged problem or acknowledged next challenge for the team that nobody has a good solution to. And you've been there for a while, so you're familiar with the problem, you're familiar with the area. And, that's an exciting place to be, I think, because you can then start to think of new ways of solving that and how to motivate that. And this outlier detection work was a case like that. And this was we needed a way to measure how much abusive automation was happening. And in particular for logged in members scraping data. And we just wanted to measure it here. And one of the challenges, there's a few challenges here. One is that there are no ground truth labels. If you're looking for spam, you can show a human, a spam example and a not spam example. And there's human intuition that allows them to differentiate those. What do you surface to a human reviewer at scale to differentiate between sophisticated scraping behavior or not? Right. So that was a challenge, no ground truth labels. The second is it's very, very unbalanced, right? The vast majority, similar to the dark matter interactions in our big detector with all this background, the vast majority of user behavior is good and organic, and there's a very small fraction that's potentially automated. So that's another challenge. And third, the bad actors it's adversarial. So they are very sophisticated. There's humans on the other side that have, that are trying to circumnavigate whatever you do to measure this abuse or stop it. So as you build models, they will try to evade them. So I knew there was this problem because I'd worked on sort of the earlier bits in this early execution phase of my career.
Yeah.
And there wasn't a great solution. And I also was doing things like reading blogs or talking to friends in other areas. And I was also going to a lot of meetups about abuse. We can talk about this, but there's a great one that used to exist before the pandemic called Deflect Risk Salon. It was like a monthly meeting.
Okay.
And a yearly
just about this specific topic? Interesting.
Just about abuse, and and it was super useful for me because I learned a lot and had the opportunity to hear how other people were thinking about these problems and compare ideas from other companies. And nobody had really solved it well, but I was able to kind of sense, okay, outlier detection is probably a right fit because it naturally fits if you don't have labels. It's unsupervised.
Right.
It naturally fits if you have a very unbalanced data set, right? Because you're looking for outliers.
Yeah.
And it naturally fits in this adversarial case because we have this huge bulk of normal user behavior. And the algorithm kind of learns that. And as long as the automated activity that you're trying to detect looks different, it doesn't matter how they're adversarially adapting because they still look, it's separated in this parameter space from all the normal users. Yeah. So it kind of intuitively made sense to me. And then I did a little POC and pitched it, and it kind of took off after there, and we use it a lot now. Yeah, interesting. Okay, so you did a POC. Did you do that as a pet project on the side, or do you tell manager, hey, I want to pitch, and then your manager asks you to do a POC? What was it like? And that's a great question. In this case, I kind of did it as a pet project. I didn't spend much time on it, but I just spent a few days. Like, it actually existed. The algorithm existed in scikit-learn that I wanted to use. I kind of did a bit of a literature review very quickly and said, okay, which is like a powerful and easy to use unsupervised outlier detection algorithm. Do you remember what package or function from scikit-learn? Yeah, it's isolation forest. Okay. And you have that on your GitHub. And I have it on my GitHub as well. And we can talk about that too. I did our own implementation and open sourced it. But I kind of chose that one because it looked like a reasonable, a good choice, and did the POC and kind of shared it and said, hey, here's this problem we all know that we want to solve, and nobody's got a great solution, and this looks very promising, and we should probably pursue it. Right. And that's how I was able to get buy-in to then have a real project to create this open source code, the code that's now open source, and apply it in a pilot use case, and then sort of build a team that applied it in many other use cases where it also fit. Yeah. And the reason we did the open source project, so that's a Scala Spark implementation of it. And the reason we made that was the Python version is kind of limited to a local machine, and we needed to run it at scale. We wanted it to fit in with our kind of Scala Spark ecosystem, and we needed the size of the data we wanted to run it on. It made sense to develop our own that could be parallelized. Yeah, thanks for sharing that. So if you want to pitch the project without the POC, do you think your manager would approve that? That would have been a harder sell. No, this is like something that is super critical, both for entry level engineers or more junior engineers or data scientists, but also more senior. Figuring out how to persuade people is super critical across everything you try to do. I think, like, not only pitching projects and trying to motivate them and build enthusiasm inside the organization for them, but also as you become more senior and you want other developers to work on it, you have to persuade them to be excited about your thing. And the product team, you probably have to persuade, hey, this is the right way to go. Even if it's a bit more complicated, it's a machine learning model instead of some manual rules, but like there's a lot of good reasons to do it. So learning how to persuade people is a key thing, I think. I would follow up on that later. So let's go back to the outlier detection. Can you tell us more about the open source library, like the function? What does it do exactly? Yeah, so isolation forests were first, I think, proposed in 2008 by unrelated. It's an academic. There's a paper about it, and you can look these up. And there were a few implementations of it, and scikit-learn already had it, so it made prototyping easy. And essentially, what it is, it's unsupervised outlier detection, and it's an ensemble of randomly constructed binary trees. So you can kind of think of it as like a random forest in some sense, like it's, this ensemble of trees. However, the trees are not constructed in any supervised way. You put in some input data, and at every node, when you're constructing a tree, you randomly select a feature, and then you randomly select a split value.
Right. And
you do that in principle until every data point you use to train the tree is isolated in a leaf node.
Isolated? What do you mean by isolated from the leaf?
You build the tree in this random process until every leaf node has only one data point.
Oh, interesting.
So this is where the isolation name comes from.
Okay.
And what you can kind of intuitively get the sense like, hey, the tree is in some sense capturing the structure of your data. And the way it does this is, if you have data points that are very similar to other data points, so they're inliers, it takes many, many of these random splits to isolate them. So they will end up with a very long path length from the root node to the leaf node, because you have to randomly do this process to split them off from all the other data points. If you have outliers, they're much more likely to be randomly split and isolated quickly. So they're much more likely to show up with shorter path lengths from the root to that leaf node. It's this path length that actually provides a score, which says how similar or dissimilar is this particular data point to all the other data points in your data set. And you train an ensemble of trees, and you can average across these scores to get an overall score.
Thanks for explaining that, because while you're explaining, I just had a question. If I have two in the second to last leaf node, and then I'll definitely separate that, but that might now be outlier. So I think that definitely makes sense. You want the isolation happened within just a few steps, right? Maybe previously there's like 100 leaves in a node, and then all of a sudden you just separate one. That definitely is an outlier. And also because of the nature of the trees, is prone to overfitting. So you're using like ensemble, so you're not overfitting or just get something random.
Exactly. And there's lots of advantages to this algorithm. I mean, as you can see, it's kind of it's just this random process, so it's very lightweight to train. It's very fast on large amounts of data. It works really, really well. So one of the challenges with outlier detection, unsupervised outlier detection, is that as you add in, you have to be tremendously careful about what features you add in, because it's not like supervised learning where it'll ignore a feature if it's not very important. In unsupervised learning, you could add a feature which will produce outliers that you don't want to detect, or at best case, it's sometimes randomly selected, and it's kind of diluting the effects of the features that actually are contributing to finding what you want. So isolation forests are a little bit more robust to that than other outlier detection techniques. So that's a positive thing. And compared to its peers in the literature, it outperforms them generally, at least in the cases we cared about. So that's why we chose it.
Cool. And does it provide feature importance score like other XGBoost or?
There are ways to do feature importance. That's a great question. And there's actually some recent literature that's isolation forest specific. There's some papers about how to get feature importance out of it. And you can also do things. One thing that we found useful is you can train a supervised model on top of the output of the isolation forest, a supervised like random forest model, and see which features are contributing to particular decisions. And like that kind of gives you a heuristic on which ones are useful or which are not.
Okay, so you do unsupervised on the first batch, and then you figure out some ground truths, do a supervised. That's pretty cool. And also, the tree-based model doesn't assume distribution of the data. I think I was going to ask, how does it compare to the traditional outlier detection, right? You have to have the assumption that what distribution does it base. So I think you just answered my question.
That's a great question too, that's another advantage, is that there's no assumptions about the distribution of the data.
Right.
Which is really really a powerful thing.
And another question I have is whether this unsupervised approach or the deep learning approach, I think in the other project you were using deep learning to detect how is a false positive or false negative, which one is more important to you?
That's a great question. And it depends. The answer is it depends.
Okay.
So in this isolation forest outlier detection, we use that for measurement. So we're not actually, stopping any of the abuse based on this. We use it to measure. And in that case, we optimize slightly more for recall. So we're
recall for the abusers.
For the abusers,
okay.
Yeah. So we can tolerate a little bit more false positives because you're not taking action. You just want to establish how much of this is happening each day. Are there new abuse attacks, and you want to make sure you have recall for those.
Yeah.
And then the other model actually that we can talk about, this deep learning sequence model, that's actually taking action to stop abuse. And that one, you optimize for precision. So there you don't want very many false positives because you don't want to take action on a legitimate member. Yeah. So that, there's very high goals for precision there.
Precision. What about the recall? Do you also have kind of a threshold for recall there? And on top of that, you optimize for precision?
So we optimize, there's some floor on precision. It's very high. And that's what we set the goal for. So it's maximize recall at a given precision.
Precision.
Target.
Oh, got it. So you want to maximize recall on a given precision. Yeah, I'm always curious to learn how other people prioritize those metrics.
It matters to a huge degree on the particular business problem you're trying to solve. Yeah, it's always different. Yeah. Yeah.
So going back to the unsupervised method, so you finish the detection, and then there's do you provide the data to a product or program management team, and then they look into it and decide whether they want to stop the count?
So with the isolation force, it provides metrics and detection of. So it enables us to have some visibility into how much of it's happening, and it enables you can also use it for training labels for downstream supervised models. So you can take your highest confidence outputs of detected abuse with the isolation force and train downstream supervised models, and that's actually what we do with this sequence model. Okay.
Yeah, I'm curious, how do you close the loop? Because it's unsupervised. So basically, my question is there got to be someone actually going to do some investigation on the account and to see whether they're, kind of a fraud account. How do you take that information back to the unsupervised model?
That's a great question. Yeah, so that's it does involve building some domain expertise in the team.
Yeah.
And on both, what exactly you're trying to detect.
Yeah.
Because you have to kind of develop features to produce outliers. The things you're trying to detect have to be outliers in the features you're using.
Yeah.
So we've developed sort of libraries of features that are useful for detecting things we want to do, and we can apply them in different areas of automated abuse. And in terms of validating the model, there's a lot of tools that we've developed to enable expert reviewers to look at the output and say, yes, this is a true positive or a false positive.
Yeah.
And there is some human in the loop there with experts to validate when we've upgraded the model or retrained the model to validate sort of precision and recall.
Okay, got it. That makes sense. And can you share more about the deep learning, the supervised model?
Yeah. So this is this is an interesting one, because this is taking action on, again, automated abusers. And one of the big challenges, there are a few challenges that motivated this. Similar to the isolation force, there are some unique challenges. There are some unique challenges that I think motivated this model. And the first is that there are tons of surfaces that you have to detect abuse on, automated abuse. And they each are owned by different teams within a big company, and they each have different data sources, tracking data sources that you have to calculate features on. And that becomes very manual labor intensive, right? If for every part of your website, you have to create specific features that are bespoke to that surface, and then train a model that's particular to that type of abuse on that surface. That doesn't scale very well. So we said, okay, can we use a single data source that captures user behavior from all surfaces? And it turns out that those exist, and there's a way that we developed to automatically encode that into a sequence. So we have a sequence of user requests as the input data to the model. So that could be like... Oh, sorry,
user requests. Who are the users?
Yeah,
so product managers?
Well, users, no, in this case, it's members on LinkedIn.
Oh,
right?
okay,
so it's account, it's you. Yeah, exactly. So it's, if you log in or log out or view profile or send a message or, post, right?
Right.
You do this in a healthy way that's, or get positive for the site. And vast majority of people do. But there could be some bad actors that want to send spam and they want to automate it, right? Yeah. Or they want to copy data and they want to do it automated. So by looking at those user requests, you can build a model to detect that type of abusive activity. And innovation is that, hey, if you have a sequence that captures every user action like this, you can treat it, and you can use NLP techniques on it. And similar to a sentence of words, and you can classify that as like, hey, this is a positive sentiment or a negative sentiment. Like that's a canonical NLP use case. Yeah. Maybe movie review sentiment or something. You can look at a sequence of user requests and use the same type of model and say, hey, this is an automated sequence or an organic human sequence.
Yeah, interesting.
And so that was the innovation there. And what it allows you to do is use the same input data and the same modeling technique regardless of the type of abuse. You're just changing the labels.
Oh, okay, so it become a classification problem, but it's also highly unbalanced. Do you do some processing to help amplify the...
That's right. Yeah, we rebalance, for training. There's some sampling of the, of each class and to produce some balanced data to train the model.
Okay.
That's a great point.
Yeah. And also, I think those, abusers, they also adapt pretty frequently to, websites policy. So is this the online model that's run in real time?
It's a great question. Yeah. So this is, and that actually brings us to another great point, which is something I think about a lot, which is when to do things online or offline or nearline. So this one currently is an offline model. It's running in a batch mode. But I think that is a critical question. I think people often think, hey, online is the best because it's the fastest, but and you can calculate the impact of a model online, and it's often higher, whether you're trying to make recommendations because they're fresher or you're trying to catch abuse more quickly.
Yeah.
But there's also costs that are not as clearly apparent. Like it's more complex. It may take many quarters or a year to develop instead of months to a quarter as it would take for an offline model. So you have to balance those things and take into account like the opportunity cost of spending a long time and investing in a more complicated model.
Yeah, that makes sense. Not everything has to be online, and when we implement a solution, we need to think about the cost and also the risk. So this model you mentioned, you take action. So if you detect, you do like stop the count for a few hours and then investigate. What do you do?
Yeah, in this case, we like to educate. So there's an education series of sort of messages that show up for the user.
Yeah.
And that's typically what we would do. And then maybe if there's you do that for if you keep getting those, then maybe that's a sign that there's something something more.
Yeah. And then what if it's a false positive? Can user appeal?
Yeah, of course there's appeals. Yeah, and you can write it, and there's a process to correct
interesting.
the record, so to speak. Yep.
Yeah. And you mentioned the unsupervised approach. There's a human in the loop, and this one is like more automated. So as a data scientist or machine learning engineer, how much do you actually learn the context, the domain knowledge to look at those logs by yourself?
You have to know a lot. I think that is a critical thing. That actually I also credit my like physics background to in this data analysis and physics. Is I think people coming from natural sciences often have that innately in the sense that like they've spent years dealing with like messy data and really they have a hypothesis they want to validate or not against some data, and they're used to sort of really diving in deeply and exploring every detail of the data. And I think that sometimes I'm not sure if I think CS might not necessarily have as much of that in the training at least, and like people learn it on the job. But I think that's super critical. You can't just like grab some data, throw it into a pipeline, train a model, and look at the metrics. Like you have to, the closer you can get to really like scrutinizing all the details and really understanding the data you have, the better it's going to work for you.
So even as a staff machine learning engineer, you're still looking at the logs and then to learn user behavior on your own.
Yeah, I mean, so these things. So I do less of this now. I think my roles have evolved over my time at LinkedIn. So like when I first started, I was just doing execution, and then these are some of the I'm very motivated by doing novel work. So like impact and relevance to the business is kind of table stakes. Like of course you should be doing that and motivating yourself, or like finding solutions to business problems and having impact in the organization. But I think what's really exciting, kind of gets me out of bed in the morning, is like, hey, for problems that are fuzzy and not yet solved, that are important and everyone acknowledges they're important, can you go and find existing techniques or cutting edge techniques that you can apply in a new way to solve them and do a better job than what the company's currently doing? And I think that was the case for both the isolation forest and the sequence stuff. So that was really fun and really the type of project that motivated me. Now I have less time probably to do like the specific innovative work myself. And I kind of work across a few different teams and try to create space for others to do this. So I have a good view of, hey, there's these problems and these novel solutions maybe could work there. And then, there's other people that do a lot of the like diving into the data and training the models and implementing the code.
I guess there's definitely a shift from a junior machine learning engineer to staff machine learning engineer. You try to leverage teams and influence them and share your expertise. So can you share with us what's your day-to-day like?
Yeah, that's a great question. So it really depends on, it's changed significantly as I've passed through these different roles. And actually there's a book, and I think a blog too, but it's called like Staff Eng. And the book is great. And there's sort of 4 archetypes, I think, of staff engineers that are described in there. There's like tech leads, which are, doing this kind of thing where you're the technical leadership of a particular team, and maybe you've solved the hardest technical problems in the past, but now you're, enabling others to do so. And then there's architects, which are, kind of responsible for the overall vision of a team or an org in terms of, are we architecting our solution the right way to solve the problems we need long term? And then there's a solver archetype, which is, hey, I'm going to go into the hardest, from fire to fire, and solve the hardest technical problems. And, I'll get it to a good state and then move on to the next one. And then there's also like a right hand, it's called archetype, which is like you leverage the authority of someone with formal authority, like some senior manager leader, that you are able to go and increase their impact by through technical means or technical influence in the organization that's kind of aligned with what they are hoping to achieve. So like earlier I was doing more of the tech lead stuff, and I still do. I think now I also do a lot of this architect view of like, hey, what long term should the organization look like? Are we using the right tools? Are we, given the technical landscape, should we be changing our strategy of how people are doing modeling to be more productive or effective?
Yeah.
And also some of this sort of nudging the organization in a particular direction based on like what other leaders think. So I do some of that too.
Oh, okay. So how do you balance this type of leadership role versus exploration of your own curiosity?
Yeah, that's a great question. I think one thing I really enjoy is partnering. I do have a lot of like one-on-ones. I'm not sure if this is unusual for a senior engineer, but I do try to stay technical and involved in a lot of these innovative projects and create the space for others to do it by syncing up very frequently with more junior engineers and creating the space for them to do really cool projects that solve problems that are, really important to the team and the company. And so there, I'm not actually doing the work. I maybe meet once a week and, give advice and suggest one thing or another, but they're really leading the projects and kind of growing themselves. Yeah. But it allows me to stay really connected with some of these more technical things.
Mm-hmm. Yeah, thanks for sharing that. And when I was looking at your LinkedIn, I found there's another pretty cool project you worked on. You created the first proof of concept deepfake video detection system at LinkedIn. Can we talk a little about that?
Yeah, that was sort of a POC. I think I don't have as much public content on that one, so I can't say as much. But that was a POC, and that was kind of again a novel thing that I wanted to try out because it was a hot thing in the news maybe a few years ago. Yeah, and there were some academic papers on different techniques to do it. So it was again a case where I thought, okay, well let's see what we can do here and maybe get ahead of the curve before it starts showing up on social media. Yeah, let's develop some expertise on that.
Yeah. I think it's a great way to learn some new technology. When you're doing that, I guess you're probably curious about it. And then I think the best way to learn is to build a project, especially solving a real problem in your company. So I think that's pretty cool. And what type of innovative project are you working on right now?
So there is still some work on this type of deepfake stuff, and the last few years, I've been doing these more architect-like projects, which are like trying to up-level the entire team in terms of like the modeling tech stack we use, aligning it with what the latest and greatest within the company is. Right. And again, like developing a strategy to say, okay, given this technical landscape and all the pipelines that are available and the tools that are available and the infrastructure that's available for models, how do we think about the ROI for every individual model we choose to build? How do we decide online, nearline, offline? How do we decide, whether to share features or not share features, or how do we decide what type of model to use? So to make us more effective, because I think those ROI calculations aren't always immediately obvious when people start on a new project.
Got it. So you make more decision on the architecture, on the processes of the team. So have you figured out a process to decide whether a model should be online, offline?
Yeah, I mean, you can kind of think about it in terms of, how long will it take to put online? How, given experience you have had with similar models, what's the impact? What's the estimated impact online? And what's the estimated impact offline? And let's say it takes 4 quarters to put a model online, and it takes 1 quarter to build the same offline model, but it's, there's a bigger latency. Yeah. So slightly lower impact. But what else could you have done? What's the opportunity cost with those 3 quarters? Like maybe it would have been better to do the offline model and then produce other models or iterate on the offline model and improve it. So it's like creating a process to force people to think through these decisions. Yeah. And hopefully that creates better outcomes in terms of impact in the long run.
Yeah, I agree with that. So sometimes, although you don't have an answer for this type of complicated question, but if you have a checklist of questions, at least it forces you to think about it, just have the awareness, oh, wait a minute, maybe this is not the best option.
Yeah, and it's not something you want to mandate or something to your team,
Yeah.
right? You want to like enable
just
them
nudge them to think about
through
it.
And then if there's tech spec or RFC processes, they can have a little section that shows how they made the decision, and they're saying, okay, we're going to do this one online, and this is why, and then they've done the due diligence there to think about it
right.
the right way.
Yeah, so they know they have to explain it, and then, And I'm super interested in the ROI of the project, because I think I also kind of have worked on that, doing some meta-analysis on the model we have built. And it's difficult. A lot of data science projects, it's more like you're validating some ideas. It might kind of, I think of it kind of maybe like a hidden layer of a neural network. It might not directly have some impact, but might indirectly have some impact down the line. And if you just say, oh, this project doesn't have, a very obvious ROI, and you shut it down, and I think it could also be short-sighted. So based on my experience, I think the measurement of ROI is also from the leadership, kind of as a nudge, like just to think about the ROI, but it's not like every project has to have like high yield. But it does sometimes put a little bit pressure on the data scientists when they, pick and choose projects. So how do you think about this problem? Like, how do you use the results of the ROI? Do you, shut down project, or is also just like raise awareness?
I think I like your point about forcing people to think through it. Like, it's the same with tech specs, right? Like in RFCs, which is, it's not, you're not stuck to whatever early design you did, but it's a mechanism to force you to have some self-discipline to think through all these details. And then you can, communicate it, get feedback, and then, get on with actually doing the implementation, and maybe it changes. I think it's kind of similar. I mean, those early estimates of impact are always like very, very rough, right? Like it's probably in your case too. It's, for planning, right? For multiple quarter out planning or something, like you're always thinking, okay, well, how, maybe it's order of magnitude. It's 10% or 1% or 25%, something like this, in changing a particular metric. But it's, it's very hard to know a priori, really, if that's gonna work. So this is actually another case where persuasion matters, because if you think you have the right answer, it's subjective, right? Like there's always like different technologies you could use, or different modeling methodologies, or rules versus models. So like if you want to, but like if you've thought and convinced yourself, hey, this is the right way to go, you need to figure out how to persuade others, because ultimately it is a subjective decision. So if you want to be effective in getting the outcomes you want, like I think that's useful.
And so do you have a framework, say if I'm a stakeholder that you want to convince to adopt some processes, or I'm your colleague, how are you going to persuade me?
Oh, so I can give an example on how it worked for sort of these isolation forests.
Sure.
So initially, like I said, I did this POC and for my own my own time in some degree, and but it was very lightweight and showed results and showed that they were, it was promising and it was going to solve this problem maybe that we all agreed we had.
Yeah.
And then you get some resources to work on it, and you try to make it like a very narrowly scoped MVP. So like you want to get something to production, and you can be willing to make approximations and, limit the scope so you can actually get something into production. Because I found like once you have the foothold and you have like something running in production, then it becomes easier to motivate the next project to improve it. Because you can say, oh, it's working and it has some impact. Here's the next steps. And if we do those, then it'll be even better, or it'll be where we need it to be. So like that process is something I've always tried to do. And then, if you want to start to scale your solution across the team, after you have it working in one pilot case, there will be new problems that are related, and you can point and say, hey, we've already solved it in this case. the easiest thing to do now is to scale that, or you can enable other teams to use it, or eventually you can open source it like the Isolation Force and give talks. And now people, in that case, actually, there are abuse teams outside of LinkedIn that use our methodology and the library I created to detect abuse. Like I know cases of like payment fraud that use it. I know cases of cheating in video games, like detecting people using automation in video games. And so I think it's this staged thing. You can't go and ask too much initially. You have to kind of build up slowly over a period of time, proving at each stage that it's the right decision. It's kind of the way I've always looked at it.
Yeah, thanks for sharing that. I think it's definitely useful because sometimes people are complaining, I'm not given exciting projects.
Yeah.
Yeah.
I think that happens with like relatively new employees or more junior engineers, right? That they feel they're not given. I think that, so I have a few bits of advice there, I think. Like one is, nobody necessarily tells people this, I think, but like ultimately you're kind of responsible. Like everyone else has like their own distractions and priorities and needs. And so you kind of have to nobody cares about your career as much as you do, definitely. Even though there's probably allies and your mentors and your manager and stuff, hopefully are all supportive and helping you. But ultimately, you should try to be coming up with ways to solve look and see what problems your organization has and what techniques you'd like to use to solve them, and try and improve it, and suggest them, make recommendations. Don't come and say, hey, we could do this, but here are the downsides, and we're not sure if it'll work. Like, you kind of need to be the champion of the solution you're trying to create.
Right.
Because the other thing is, like, if you're going and pitching something, everyone else is pretty much going to be less enthusiastic. You're setting the upper level of how enthusiastic people will be. And like everyone else is only going to be like less than that. So like if you're already pessimistic to start with, which I sometimes see with like newer people, like you're setting yourself up for people not to be too enthusiastic about your idea.
Right.
But I mean, you definitely need to convince yourself that it's the right way and the right thing to do. But when you do that, you should try to set the bar high in terms of motivating it.
Yeah, that's a great point. And especially provide a little bit evidence. Where data scientists, you don't have to wait for 3 months and provide a model with like 99% accuracy, but something tangible for people to see it. In my previous interview, I interviewed Eugene Yan. He's applied scientist in Amazon, and he said in order to persuade business leaders, he also create a UI for the product. So everyone can go play with it and engage with it. It's also a way to get buy-in, create something tangible.
Yeah, that makes sense. Yeah, definitely communicating the progress and communicating results that way, and have a UI is a great one. Yeah. And also, give talks about it, even if it's not in production yet. Don't hesitate. There's all these forums generally in a big company for sure, but where you can go and give little road shows about accomplishments and progress on your POC or new modeling techniques, and people are generally pretty receptive to that. Yeah,
I love that. I think people always, especially for data science engineers, some people are like, I don't like to do that. It's not like I want to be famous. I don't have to, show my work that way. What do you think about that?
Oh, I think this is another case where you have to, you don't have to. Everyone's motivated differently, but I think it helps if you want to have a big impact to publicize your work internally and externally, and it also is helps with persuading people, because you build sort of this canon of this library of accomplishments, and you build your communication skills, and I think all of those things help when you try to do something new in the future.
Yeah. So how I see it is people who go, give talks or share their work, it's not like, oh, they just want to, be famous or something. Think of it as a way that other teams might benefit from your methodology. If you don't share that, they might use something, outdated, they might trap in a problem. So you actually might help other teams. So go from that perspective so that might help you feel it's easier to, put yourself out there to give a talk, write a blog post. And then I really like that you mentioned even in the middle of the project, you can go give a talk, right? Because sometimes giving a talk is not just about showcasing your work. It's also about getting feedback. So if someone tell you, hey, maybe, there's something wrong with it, you don't have to get defensive. You can engage in a healthy, thoughtful discussion.
That's exactly right. Yeah. I mean, because you get good input, and also you find people that the ultimate goal is to get people to use what you're building.
Yeah.
And if you're able to get people outside your team to do it, that's like a great feather in your cap generally in terms of impact, because it's not no longer just in the scope of your immediate team and your immediate problem, but if other people in the company are using it, that's a great thing.
Yeah. And from the beginning of your career to now being a staff engineer, how did you gradually learn those leadership skills, especially, for persuasion and influence?
So I did luckily get some opportunities in this physics career of leading different components in that experience. So I had that experience, although industry is a bit different. And I think I always had the mindset, actually there's a phrase, I don't know, I think it might be Napoleon, but I'm not sure, it might be misquoted, but it's like when starting a new project, it's commit yourself, then see. So people talk about imposter syndrome, or there's some being concerned when you're trying to do something new. Or let's say you're doing trying to motivate a complex novel project to solve a real problem that you've done some POC work. Of course, you're going to feel a bit uncertain. There's a lot of unknowns you're going to have to overcome and figure out along the route of 3 months or 6 months or 9 months of work. But you kind of need to have confidence in yourself. Hey, I'm going to commit myself to doing this and persuade everyone, and then I'm going to figure it out.
Yeah.
And we'll figure out a solution. So you don't want to undermine yourself too early. And then in terms of persuading people, I think there's one thing I've been kind of interested in the last few years is influence and persuasion and how to be more effective. And I think that's super critical regardless of your level, whether you have just started in industry out of school or whether you're very senior. Definitely matters for managers, right? They have to be able to, they're in meetings all day and have to operate, with people. I think it might even be more important for very senior ICs because, or at least as important, because you don't have direct authority, right? So you have to have a big impact over a big organization with partner teams, and you have to do some managing up, and you have to, also work with, get buy-in from all the ICs that are more junior, as well as partner managers. And you have to do it all indirectly. You don't have employees that report to you. You're just indirectly meeting with people and trying to convince them to get aligned with what you're trying to achieve. Yeah. So I think that's been super useful. And I've been reading books about that, and I think and trying to apply it.
Yeah. So basically, how do you lead without a title? Can you share some tips specifically about how can you do that?
Yeah, I think one of the things is you need to establish, it's good to establish technical credibility, right? So you want to have done some technically complex projects in the past. I think it's because then others can kind of look at that and view you as an authority. Right. And I think that's helpful. And I think there's also, it's also very useful not to be above doing boring work or mundane things too, and kind of you're not just delegating things to more junior people. You also are willing to be in the trenches alongside them in some sense. So I think that's very critical. I think it's it never hurts to give people credit. I think it never diminishes your contributions generally. So like if you're working on a project and you're leading it, like don't hesitate to like have the people that are doing the work that are more junior, they can go be the first name on the presentation, go give these roadshow talks, because that motivates them. It makes people want to work with you. It also, it's kind of fair, and they're getting rewarded in visibility. And maybe you already had it, right? Like everyone knows who you are, maybe in your organization, but these newer people can benefit from that visibility. So I think that's a good thing to do as well.
Yeah, thanks for sharing that. And you also mentioned managing up, and now you meet with junior engineers. And from your perspective, what can they do to work with you better, to manage you, basically?
What can junior engineers do?
Basically, like how can people better manage up?
Yeah, I mean, I think one thing I love to see when they're more junior engineers is for them to come with recommendations whenever they're like, if they're data scientists and they've done analysis and they're coming to a meeting or they're coming to one-on-ones, or they have project ideas, or they have a problem. It doesn't have to necessarily be right always, or it doesn't have to be the way we definitely go, or maybe they aren't completely sure, but like it's way better to always come and say, hey, here's the problem, or here's the work I did, and this is my recommendation on the way to go.
Right.
And, maybe there's some debate about it, but like often you'll go, oh, okay, that makes complete sense. Like that sounds great. And that also enables them to have more influence and more control over the direction of their project or their career. So like, I think that's a super useful thing.
Yeah. Have an opinion.
Exactly.
The data and the model never speak for themselves. And it's okay, your opinion is wrong. It also provides something for people to discuss.
Yep.
Yeah.
Yeah. And I mean, too many times you'll see in, maybe a big meeting where people would come and say, here's all the results, here's these complicated analyses and these results, but with no next step or recommendation.
Yeah.
And it's very hard for more senior people or a group to absorb it all in 5 minutes and make a decision collectively. Like you kind of need this anchor of like, hey, I've gone away and thought about it and I'm coming back with my recommendation, and then you can debate the merits of that recommendation. So I think that's a good thing to do.
Yeah, I think that's a great approach. And there will never be a perfect data science model. When you present your solution, there's always going to be people disagree with you, provide feedback. But at the same time, like you mentioned, you need to kind of champion your own solution. So how do you balance, advocating for your own solution versus also keep an open mind, taking feedback?
That's a great question. One way to do it is, try to solicit feedback early in the process and continuously during the process, so that you can, rather than it being, hey, I've done a lot of work and now it's, one solution or another, or people, or you may need to revisit a lot of the work you've already done based on late feedback. It's good to like get everyone's input along the process. And also this makes people feel ownership in the same problem. Right, so they're going to be more agreeable later on because they've been there the whole time with you having these discussions. Yeah, so like that's another good way to do it. So you'll end up with it'll be more pleasant for you from a people perspective and more efficient, and also you'll end up with a better solution because you'll be getting this technical input the whole way.
Yeah. So during your career, what are some mistakes you made?
I think I probably waited too long to start to think about this influence stuff.
Okay.
I mean, I was always okay about it, but like I feel it's actually like it's a revelation once you actually like realize, oh, there's like a canon of literature about this where you can go and read how to do this effectively. So I think that's one. I focused very much on like technical problems and solving them, or like especially earlier in the physics time. I think another is other people, like recognizing that everyone has different motivations. Like I've been talking about, hey, I like to solve these hard problems with novel, bringing novel ideas and doing it better. Like not everyone cares about that actually. Other people may have completely different motivations for what they want out of their career or what they enjoy doing at work. And, as you become more senior and you're actually influencing more junior people, recognizing that, hey, they might be motivated by completely different things. So like finding opportunities for them that are aligned with their strengths and interests is something to always try to do.
Yeah. Do you have some book recommendation to help, like, if you want to learn about how to find out other people's motivation?
Yeah, I mean, well, for influence, definitely there's Robert Cialdini is kind of like the master of influence, and that book I cannot recommend highly enough.
Yeah.
And often you'll actually read it and you'll think, oh, this is kind of common sense, but actually having it all in a framework that you can apply is super useful. And it also helps you recognize when other people are trying to influence you. And it's super useful whether you're trying to, work with your partner managers and influence them to work on projects that you need as a senior engineer or you would like to do, or, again, the managing up thing, or, persuading more junior engineers to be excited about projects that you're involved in. So I think it's just helpful across the board. I think I mentioned the Staff Eng book, which I definitely would recommend. I think it's also useful to read books about management. So like there's
even if you're IC.
Even if you're an IC.
I agree.
For a few reasons. I mean, there's the famous one, The Manager's Path, I think Camille Fournier, and which is a good one to start. And the reason it's important is, one, that's a potential career track. So like you might as well learn like what's involved there and whether you'd want to go that route or not. But two, like you're interacting with managers every day, like both your own as well as others and other senior leaders in the organization. So it's very helpful. You've not had those roles probably. So it's very helpful to realize like, okay, what are they concerned about? What are their incentives? What are they responsible for generally at a given level? What is a good one versus a bad one in terms of, who's operating well? How are they interacting with you? Like there's tricks that they learn in these books in terms of interacting with ICs and people they manage, like being aware of what, all of that. Like it just makes you more effective. And it makes you more effective in being able to deliver on what helps your manager the most, for example. That's a very obvious one. So I think it's good to learn from the manager's perspective as well, even if you don't want to go that route.
Yeah. So I also read that book and also some other people's talk about influence. I think before I learned about influence and negotiation, I just feel like those are techniques for you to manipulate people. But actually, a lot of time is for you to find out what are other people interested in and find out win-win situations. But I do see some people, when they try to influence you, they're trying to manipulate you. So when you try to persuade and influence people, how do you present yourself as someone who is genuine?
Yeah, no, that's a great point. I think the win-win situations is key. Like you always want to be pretty clear about what's in it for me and what's in it for you.
Yeah.
And ideally, you're able to say, hey, this is a win-win, and we're both going to come out better as a result of this agreement. And that's a very persuasive thing in itself.
Yeah.
And I think if you do that transparently, like then it's not too manipulative there.
Yeah.
Yeah.
And also I think it actually earns more trust if you just be honest, right? There's something for me, I want to do this because maybe this helps with my promotion or my team. So actually I don't really trust someone when they say, oh, I'm just doing this because it's for you. And it's like, what are you actually,
That's exactly right. And it's kind of skills like anything else. It's skills like, you could say that like doing technical presentations is a persuasive thing.
Yeah.
You could either do it well or you could do it badly,
right.
But you might as well like learn the skills to do it effectively. And I view the sort of normal persuasion in day-to-day life is the same.
Yeah, I think that's very important. I think the most important thing is about the intention. It's not the specific technique. It's not about the words you say. Of course, those things matter, but I think when you go persuade someone, just have the mindset of, do you just want your ego to win or you want to complete the project? So separate yourself from the project sometimes helps you to have an open mind. Oh, maybe the other person is right. And you don't have to be, have this attachment to your own methodology. So throughout your career, do you have any mentors that help you grow?
Yes. Yeah, that's a great question. I think, so I was incredibly lucky to work with my advisor for this during this physics period, because that was an opportunity where
your advisor at LinkedIn
my advisor in physics,
physics
at Brown, because I mean this dark matter thing was super competitive, worldwide efforts, and competing collaborations for over the period of decades, and he was one of sort of the world leaders in this, and had been for decades, and so being able to work with someone like that for a number of years, you kind of see what it takes to operate at that level. And maybe it's not physics anymore, but you see the level of focus, the high bar, and when it makes sense to have just super high bars of quality on particular technical things or presentations, or how much practice behind the scenes goes into it, or how much thought behind the scenes goes into the work before you share it. So I think all of that was tremendously helpful. And I've actually, I think, not just mentors, but I also have had a bunch of close friends that I've made over my career, starting in physics, and a lot of them are now doing data science and machine learning in the Bay Area. And through the physics stuff, through the insight stuff, making connections, and now at LinkedIn, and some people I know at LinkedIn that are now elsewhere. You kind of build these connections over time where you can get trusted input from people.
Right.
Get both technical, but also just like industry perspectives or career direction perspectives, things like this. Like it's super helpful over time.
Yeah, you can learn a lot from your peers. So about your advisor, what are something specific you learned from him, either mindset or like the way he works?
It's a great question. So he actually had a phrase called you want to like find technologies that have a low Sisyphean index. So this is a phrase he would use. I think he coined it. And Sisyphus is in Greek mythology this guy that he was kind of condemned to push a big boulder up a mountain every day, and he'd get it to the top, and the next day it'd roll down, and he'd have to do it again and do this for eternity. And you can kind of think of technologies as this in the same way, which is there are some that are kind of, they can solve the problem maybe that you're trying to solve, but like you're going to be manually pushing this boulder up to keep it running every day. Like maybe it's going to break, or it's very complex, and it's just an enormous amount of effort to maintain it operating. And then there's other solutions which just want to work, and because they're so well suited to the problem, and they're generally simple, or hopefully simpler, and like those are the ones that you should really try to pursue. So that's something I try to keep in mind.
Okay. I guess just pick some solution that's solve the problem, but also low maintenance.
Yes, exactly.
Yeah. Oh, that's great. And now, do you mentor people?
I do. Yeah, I do. So I do a lot of these one-on-ones with people in my organization, like, and I'm trying to get like work on technical projects with them. And I do put a lot of effort into that, and I enjoy it. I think it's great, and it's also a way to expand your influence as well. Like if you can get people to buy in and work closely with them in projects that are aligned with your broader goals, like that's very effective. But I also externally, this Insight program, there were always like later batches of people going through it, and part of the benefit was, they not only get your foot in the door for interviews, but they do a bit of training, like they tell you what to study for a month to pass tech interviews, and they have alumni come back and give mock interviews to their current crop of people. And so I did that for quite a long time. I would volunteer many times a year going back and doing mock interviews, and trying to help people trying to break in, doing the same thing I did out of academia into the tech industry, giving them advice on how to do that.
Yeah. So what is your best advice for people you mentor?
Oh, that's a good question. I mean, I think we've discussed some of it, which is like you're going to care more about your career than anyone else, and you have to take responsibility for championing the projects you want, or making recommendations and supporting them with POCs and supporting them with data, and then I also like recommend some of these other books that we've discussed as people are looking to scale up or like become more senior ICs. I think those are super helpful.
Yeah. And what are some common mistakes you see they make?
I think we've talked about some, but like one is like not communicating, like thinking that they can put their heads down and do great work, and that's going to be enough. Like in some cases, maybe if you have a great manager, that could be enough to get you a promotion or get you to the next level. But, if you really want a lot of impact, you do have to be your own kind of spokesperson a bit. You have to, it's always helpful to have other people and leaders know who you are and what you've done, and whether that's for promotions or whether that's for, yearly reviews. Like it's very, very good, because I hear what you say when you're like, some people are like, oh, we don't need to do that, we just need to focus. But I think it's always better to be known for what you're doing. Actually, this is in academia. There's a saying, if you're trying to get a professor position, which is generally very hard to do. They call, the school that's trying to hire you calls a lot of other schools, and gets other experts in that area, other professors to comment on your work, and like they could say things that are very, very good or very, very bad about you, but in both cases, that's better than saying, oh, we don't know who that person is. Because at least you have like strong opinions, and you're, obviously, hopefully it's very good, but like, it's better to be known. Definitely in the academic case, it's better to have strong opinions and be known and have like champion one direction or another. And that's a good thing. So I think here you want to be known for good things, but it's important to be visible.
Right. Yeah. Even if you just want to focus on the technical work, it helps other people to just know your work. Maybe they want to collaborate with you, right? And also maybe have more trust in your work, and you can scale up your work and also build more impact. So what did you learn from the open source project you built?
So actually, before I made that, I did not know Scala. So that was I actually learned Scala to create the library in Scala. So that like there are technical skills I learned a lot of, and I hadn't really used Spark. So I kind of learned that. So it was a very steep learning curve, which is actually something I've always liked in my career, is like I'd get bored if there aren't like new challenges and with a steep learning curve. Like things are fun until you kind of master them, and then you want to learn something new or try something new. And then, the open source contribution process, both internal to the company, but also, how it works generally in open source community. Like that was kind of a useful thing. There were some external tools that were kind of fun to use in terms of like GitHub and open source continuous integration and deployment systems, which, at a big company, you probably have custom internal tools to do this. So it's kind of like, you're able to go and learn this lingua franca that others are using. So that was kind of good. And I think it also gives you a lot of exposure. Like people reach out to you and to ask questions or to say, hey, we're using it, or hey, we're using this new way. What do you think about this? Or do you have any advice? So like it allows you to make connections that way too, which is pretty cool.
Oh, that's awesome. So now, how do you keep learning a new technology, new tools, new models?
Yeah, I think so. When I was early, I told you there was this thing called Risk Salon, and I would go to these meetups every month. And
how do you find a meetup? You just Google it.
There were some other people on my team that would go, and I think I really bought in heavily on it because I thought this is very valuable to make these connections early and learn what others are doing. So that was super useful. And, even if you're not in abuse, maybe you're in some other area, but definitely there are meetups about it, and going to those is very useful. Now, like, I do go to conferences or watch conference talks, give talks as well, like, which is always useful because, again, people will reach out to you about the work you're doing, and then you can make connections with other people that are doing similar things. So, like, that's very useful. I do try to keep up on like academic papers about certain areas that are of interest, and usually like to try and bring ideas that other companies are using, or maybe they're more academic ideas, and bring them in and leverage them when it makes sense.
Right. So academic papers, and also maybe other companies' technical blogs. Technical
blogs are great. Yeah, it's often more digestible or like easier to use, and maybe they then link papers from the blogs. Like they usually say, "Hey, we've like these are some citations," and that's useful too.
Cool. What are some areas of interest besides the topics about online abuse or online detection?
In professional interest?
Yeah.
I do actually really like the abuse area because of the unique challenges. That's actually what's kept me at LinkedIn.
Okay.
And kept me in this team. I mean, there's actually a few reasons. One, the team is, I really like, people are like really brilliant and like really nice, which is important.
Right.
And the thing is, though, the challenges are so unique because like this very unbalanced data, the lack of ground truth, the very, very adversarial nature of it, like that's different than other machine learning areas. And maybe there's probably some that have some similarities, but I really like this combination of challenges. To me, it allows for more creativity, maybe than, creating some new features and putting them into a big model that's shared. Like, you have 20 people working on one model that is, and you add a few features and get 0.5% lift in some metric. Like, it's all right, but not super exciting for me. Like, I kind of like this, like, hey, there's really unknown problems that nobody solved, and if you're able to do a better job, you can have a lot of impact by doing that. Yeah,
cool. Thanks for sharing that. And since you mentioned, then what about your interests outside of your professional life?
Oh, yeah. So back when we were in the office, I used to play basketball every week, at least once a week, and I did that for a few years. So that's pretty fun. I'm looking forward to starting that back up, actually, now that that people are getting together again after the pandemic. And I think, in lieu of that, I kind of picked up running during this pandemic and have been doing that pretty regularly. And I do play a bit of guitar too. I had one, so I played since I was young, and sort of took a bit of time off of that during grad school because I was so focused on just trying to graduate. Kind of have to have like this mindset of like, I'm going to do this no matter what, and like to stick that through. But I've been recently getting back into that as well.
Yeah. So what do you do when you have a stressful situation? Say you have a project you're about to launch, but nothing works or something breaks.
I think it's always good to take a break from it for a night or something and worry about it the next day. Like it's often like, especially if there's like stressful meetings or stressful emails or like about the project, like it's always good to be like, okay, I'm going to think about this in a different state of mind and like come back. And I find that like that's a general rule I've had for a long time, which works well. I think clear communication of expectations, and this is again where some of this persuasion comes in handy. But like before you're even in that situation, really communicating clearly and making sure everyone's expectations are set appropriately will help. And then if things start to change or if there's unforeseen problems or things take longer, like communicating frequently about that really can help lower the stress level. Because I think people generally understand if you say, hey, it's harder for X, Y, or Z reason, or there's, this other thing that's broken that needs to be fixed that's blocking us, or, or there's a feature gap that needs to be solved, or things like that. Like, I think, people generally understand.
Yeah. Right. So basically have that difficult conversation early. And if you feel like you might need more time, ask for it. Don't just say the last minute, oh, this thing doesn't work.
Definitely don't do that. Definitely don't the day before be like, hey, actually, we need another month or a quarter or something. Like it's good to just communicate the whole time about status.
Yeah. And going back to your career, so you were in the physics research for 10 years. What made you want to do the transition?
Yeah, that's a good question. So part of it was I was doing it for 10 years. Yeah. So and I like these steep learning curves. And the time scale of those experiments is about 10 years, like from starting to design it to like running it and then getting results and publishing results. It takes a long time. So there's kind of a question of like, do I want to do another 10-year stint? There's a bigger and better and fancier experiment going on now with a lot of the people I used to work with. Okay. Which is, taking another 10 years roughly.
Yeah, you're still in touch with your old research.
Still in touch, yeah. And the question is like, do I want to do it the same thing but bigger? Or maybe go into some adjacent field in physics? Or there's this really hot area of machine learning and industry, which seemed like a good opportunity to take because like a lot of the smartest people I know were going this route. Yeah. So I followed a lot of my friends in that way. And I was excited about the fact that it was so diverse in terms of application. It doesn't just have to be abuse. It could be, there's people that do ads. There's people that do self-driving cars. There's people, there's a whole world of how AI can be applied in the real world. So I thought, okay, this is an opportunity to like go get experience in industry, and then if I want to, I can switch and do these other things and continually be in a situation where I'm learning a lot and doing something challenging and new. So that appealed to me. Yeah.
Do you see yourself going to another kind of completely different industry after 10 years?
I have no plans for it yet, but potentially. So far the abuse thing has kept me like anti-abuse has kept me interested.
So what do you think about the future of machine learning? Or I don't know if you want to talk about maybe there's a future for this online abuse, if you want to talk about that as well.
Yeah, I think it's hard to predict. I mean, it's gonna be infused into everything. I mean, you already see it, like the machine learning and AI. I think in terms of future for abuse, I think that's also going to become more and more important. We see it since I joined and started in this industry, 5 or 6 years ago. I think the importance has increased. We've seen in the news, data privacy. Yeah. Online, different types of online behavior and how to moderate it or not, or how to make safe online environments. Like there's only more focus about that. Yeah. And simultaneously, I think like cybersecurity is related field, which a lot of the same techniques can be leveraged: outlier detection, identifying abusive sequences or suspicious sequences of someone's behavior. So I think, that's increasingly becoming an important thing with in the world as well. Yeah. For regarding cyber attacks or cyber warfare, things like this. So like I think there's probably a big future in that direction too. Yeah. With some related techniques. Yep. Right.
And that kind of requires more engineering skills. And I'm curious, now when you build a team for folks to do machine learning, do you hire more people with statistic, data science background, or more people with engineering background in data transition?
It's a mix. So yeah, my team, the team I work on, is very diverse in terms of background, which is really cool. That's another reason why I love working there. Is there's physicists, there's computer scientists, there's mathematicians, biologists, people with different types of other like mechanical engineering backgrounds. Like it's just so diverse, and everyone brings something different to the table in terms of the way they think about problems. So I kind of like that. That's what I would say is like there's no particular archetype of the background we're looking for generally, but it's the diversity actually adds a lot. Yeah.
Before we wrap up, what is something exciting now in your work or in your life?
So, I mean, I think we talked about a few of them in terms of work. It's, these sequence stuff is scaling to new use cases, and the blog was about kind of the pilot use case, and we're using it more and more. So that's very exciting. And there's a few other ICs that are increasingly helping and working on that, or actually leading the work now.
Yeah.
So I'm very excited about that, and very excited about sort of the role that I have now, which is trying to enable the whole team to be more productive and more effective and have more impact. And what decisions we can be making in terms of modeling strategies to achieve that.
Yeah. So you're already in a leadership position. Are you interested in become a manager down the line?
I wouldn't rule it out completely, but I really actually like the IC leadership role.
Yeah.
I like, you can be a little bit more tied to the technical details, I think. And I like the indirectly influencing technical strategy, or like setting technical strategy and then indirectly influencing the organization in that direction. Like that's been pretty fun for me, so I'm enjoying that now.
Right, and you don't have to write a lot of promotion reviews.
Promotion review packets and performance reviews and all of this, and
Yeah. Well, I really enjoyed our conversation. So for people who want to connect with you and find you online, read your blog posts, where can they find you? Yeah,
so the best place to connect with me is on LinkedIn. That's where I'm most active. And so just search on LinkedIn for James Verbus, and I'll probably show up there. And I do have a Twitter as well. I don't use it very frequently. So I think LinkedIn's the best place.
Cool. I'll link it in the show notes. Thank you, James, for coming to the show. I learned a lot from you, and looking forward to keep up with your future work.
Thanks, Daliana. Had a great time.